The simply supported wood beam is fabricated by gluing 160 mm by 80 mm planks as shown. Calculate the maximum shear stress in number 1, the glue, and number 2, the wood. The first step is to draw the shear diagram. In order for us to draw the shear diagram, we have to find the reactions. To find the reactions, we resolve the resultant of this uniformly distributed load. The resultant is located at the center and has a value which is equivalent to the area of this load. The base is 6 meters multiplied by the height of the load diagram, which is 8 kilonewton per meter. You cancel the meter, then you get 48 kilonewtons. Now, since the beam is symmetrical, you can just divide the total resultant with the two supports. So here we divide 48 kilonewtons by the two supports. So therefore, each support will react with a value of 24 kilonewtons. At this point, we can now draw the shear diagram. "24 kilonewtons is directed upward." This is a concentrated load, so the shear diagram goes abruptly upward with a value of 24 kilonewtons. Then it goes down by the value of the area of this load diagram. And the area of this is 48 kilonewtons. Directed downwards, so it's negative. So 24 kilonewtons minus 48 kilonewtons, that will be negative 24 kilonewtons. The load diagram is 0 degree, therefore the shear diagram is on the first degree, meaning a straight line with a slope. So you just have to connect the two values with a straight line. Yep, straight line. And this is now your shear diagram. Next, we compute the value of the moment of inertia, or I. Now, for rectangular sections, I is having the formula of BH cubed over 12. B is equal to 160 mm. H is equal to 3 times 80, or 240. Cube over 12. And that will be equal to 184.32 times 10 to the 6th mm to the 4th. At this point, we are now ready to calculate the shearing stresses, first in the glue and second in the wood. To calculate the shearing stress, we use the formula tau, or shearing stress, equal to VQ over IB, where Q is the first moment of area, V is the maximum shearing stress as solved in the shear diagram, I is the moment of inertia of the section, and B is the width of the section. For part 1, for the glue, we consider the area above the glue line. This is the glue line, and the area above it is this. I will shade this one so that you can visualize what the area of the glue is, or area above the glue. This is the centroid. Now Q is defined as the first moment of area, or AY. We consider the area of the shaded portion. So here we have base, which is 160, and height, which is 80. And our Y is the distance from the centroid of this area to the neutral axis. Now, since this is a rectangular section, the neutral axis is located at the center of the section. This is your neutral axis. So therefore, the distance here is, since this is 80, 40 above, 40 below. Here we have 40 also because this is 80. So therefore, the total distance is 80. And that will be the value of your Y. So multiplied by 80. And the answer is 1.024 times 10 to the 6th power mm cube. So we are now ready to substitute so that we can solve for the stress in the glue. Tau is equal to V. We use the maximum shear absolute value. So we have 24 kilonewtons. 24. Now, the ideal units to be used for stresses is Newton and mm, so that we can get megapascal. So we convert this kilonewton directly to newtons by multiplying it with 1000, or times 10 to the 3rd power. The value of our Q is 1.024 times 10 to the 6th power over I. This is our I. It has a value of 184.32 times 10 to the 6th power. And B is, of course, this one, or this one. This is 160 mm. Then you get 0.83 megapascals. This is, by the way, for question number 1. For question number 2, calculate the maximum shearing stress in the wood itself. The maximum shearing stress happens at the center because this is a convergence between the tension zone, or above is compression and below is tension. So this is the convergence of the tension and compression. So therefore, this will have the maximum shearing stress. Using the formula again, tau is VQ over IB. But this time, your Q will be different because you are now considering the area above where you want your stress to be found out. So you now consider this entire area. Alright? So Q, considering the entire area, is base, which is 160, times height, which is, remember, 80, 80, 80, that's 240. Half of 240 is 120. So that will be 120. And the y is the distance from the centroid of that area to the neutral axis. Now the centroid of 120 is here, and this has a value of 60. So multiply it by 60. And you will have Q equal to 1.152 times 10 to the 6th power mm cube. Then after computing for Q, you will now plug in the value to this equation. So tau is equal to V. We use still the maximum shear, which is 24, and we convert this one to Newton, so 24 times 10 to the 3rd power multiplied by the Q of this, so 1.152 times 10 to the 6th power over I. We still use the I of the entire section, so that will be 184.32 times 10 to the 6th power times B. This is your B. 160. And you get the answer. 0.938 megapascals. Why did we get megapascals? Because our units are in Newton and mm. If the units that we substitute in the formula are Newton and mm, we automatically get megapascals. So in the glue we get this value, and in the wood we get this value. Thank you for watching.